Okay, in this video I'm going to go over some math shortcuts, mostly in arithmetic, and show you how they work. I'll be using a couple of formulas from algebra. So let's look at the first one. If you have x plus y squared and multiply that out, that'll give you 2x squared plus 2xy plus y squared. Okay, in other words, squaring a binomial. That's your formula for squaring a binomial. The second one is similar, except it's the difference of two terms instead of the sum over here. X minus y, quantity squared, is equal to x squared minus 2xy plus y squared. I'm going to use one of these formulas to derive a formula for squaring, say, a two-digit number. But I want you to show you that you can actually use these formulas in some of your shortcuts. So let me just go over a brief demonstration. First, let me just show you something very basic. Okay, let's suppose I have 5 squared. And of course, we know that 5 squared means 5 times 5, so that's 25. Okay, but I'm going to use the formula just to, again, you wouldn't do this. If you're going to square 5, you just do it. You wouldn't use this formula, but just to show you how it works. 5 squared can be written as 4 plus 1 squared. Okay, so now I have it like the first one. So according to that first formula, I would square the first term. The 4 then represents the x, and the y would represent the 1 represents the x. So 4 is x, and the 1 represents y. So it tells me to square the first one, or the x, that's 16, plus, then 2 times xy, so it's 4 times 1 times 2, so that's 8. And then I square the y, which in this case is 1. And I get 16 plus 8 plus 1 is 25. Okay, so computed this using the formula. Now I could also write this as 5 squared is the same thing as 6 minus 1. And apply the second formula. Okay, so the 6 represents the x and the 1 represents the y. So this tells me, okay, square the 6, or the x, 36, and it's minus twice the product of 1 and 6. That'll be then 12. And then plus the 1 squared. Okay, 36 minus 12 is 24, and 1 makes it 25. And that's the way it works. Okay. Now, I also want to show you that every two-digit number. So what we're going to look at is using a shortcut for squaring a two-digit number that ends in 5. So let me show you that 25 is a two-digit number that ends in 5. That can be written as 2 times 10 plus 5. Okay. 37 would be 3 times 10 plus 7, and so on. So you can write any two-digit number ending in 5 in this form. Or I could give you a general formula and say any two-digit number that ends in 5 can be written as 10t plus 5. Okay, so in this case, the 25, the 5 would be in the 1's position, and the 2 would be in the 10's position. If it's a three-digit number over here, this would be in the 100's place, okay? So here, the t in this formula represents the digit in the 10's position. In this particular case, it would be 2. T would be 2, okay? So keep that in mind. So let's clear this. Okay, and then I want you to consider I'm going to take a 2-digit number, 10t plus 5. So t could be 1. So this would be just the number 15. T could be 2. This would be 25. T could be 3. Then this would be 35, and so on. So it's just a general representation for a 2-digit number that ends in 5. Okay, so I took the first formula then. I have it as a binomial squared here. So I squared the first term, that's 10t squared, gives me 100t squared. And then it's, remember, it's double this product. So 5 times 10t is 50t times 2 gives me 100t. And then plus the 5 squared is 25. So the 10t represents the x in that first formula, and the 5 represents the y. Okay. So now from right here, all I did is factor out 100. Okay. T. Took out 100t from these first two terms, and so I can write it this way. Okay. So now let's look at the whole thing now. This is telling me that 10t plus 5, or a 2-digit number that ends in 5, squared is equal to, okay, so it's saying multiply the number in the tens position by one more than the value, okay, and that is multiplied by 100, and then you add the square of the, in this case would be 5, which is 25. Okay, so this is then telling me that to square a number, you basically multiply the first digit by one more than whatever it is, and then add to that the square of 5, which is 25. So for example, it's telling me this. If I have 15 squared, what is square? 15. Okay. First digit is 1, so this is saying add 1 to that first digit. In this case, it's a digit in the tens place. Okay, because we're looking at 2-digit numbers. So 1 added to 1 is 2. Okay, and then you multiply those two values together. 2 times 1 is 2. And then you square or add 25 if you want, because that's what you're going to do. Okay, so in other words, we're saying that any number that ends in 5, if you square it, it's going to end in 25. So 15 squared is 225. Look at the next one, 25 squared. Okay. All you have to do is add 1 to the 2 next to the 3, and then you multiply the 3 and the 2. Okay, you get 6. And then this is 25. Now, if you're looking at the formula, you're saying, well, yeah, the formula says 2 times t plus 1, so I'm adding 1 to that digit, but where's 100 from? Where's this 100 from? Well, remember, now this 6 right here is in the hundreds place, because the 5 is in the ones, the 2 is in the tens, and the 6 is in the hundreds place. So yeah, I am multiplying by 100 because it's in the third position, but the first position here. Okay, 3-digit number now, so that's why you have this 100 here. Okay, let's look at 35. Again, what this formula is saying is if you're squaring a 2-digit number that ends in 5, it's always going to end in 25. So all you have to do is figure out the first part, and you do that by, again, adding 3 or adding 1 to the first digit, which is in the tens place. In this case, it's 3 and 1 is 4. And you multiply. 4 times 3 is 12. And it ends at 25. So 35 squared is 1225. Try another one. 65 squared. Okay. add 1 to the 6, that's a 7. Then multiply those two. 7 times 6 is 42. And then they're all going to end in 25. Okay. Okay, let's try. Let's try 95 squared. Remember, they all have to end in 25. They have to be 2 digits numbers. Okay, so 95 squared, we add 1 to the 9, we get a 10. And then we multiply those out, we get 90. And then it ends in 25. Okay. So very easy to impress somebody by doing something like this, okay? Again, it has to be a two-digit number that ends in 5. And you can extend this to 3-digit numbers, but I don't think there'll ever be an occasion where you have to square a 3-digit number, but you can extend the procedure. The other thing I wanted to show you is, let's suppose you have something like this. Say you have 49 squared. Okay, obviously what I just did is not going to apply to something like this. But anytime you're squaring a number and it's close to some round number, like say 50 or 100 or 1,000, you can apply the formulas that I went over. So you can say, okay, 49 is the same thing as 49 squared would be the same thing as 50 minus 1 quantity squared. Okay, 50 minus 1 is 49. So then using the second formula then, I would square the 50. So see, it's easier to square when it's a raw number like this. 50 squared is 2,500. Then it's minus, double this product. 1 times 50 is 50. You double it, you get 100. And then it's plus the square of the second value, which is 1. 1 squared is 1. And then you just compute this out. 2,500 minus 100 is 2,400, and then you add the 1, so you get 2,401, or 2,401. Okay, so that's one way you can shorten the process of squaring something like this. Okay, now if you have something like, say, 51 squared, then you can think of this as 50 plus 1. Okay. In this case, using the first formula, 50 plus 1. And then again, squaring this out, 50 squared be 2,500. And it's plus twice this product. 1 times 50 is 50. You double it, you get 100. And then you square the 1, add it to it, and then you just add the total. 2,500 and 100 is 2,601, and this comes out to 26. Oh, 1. Okay. So it's a nice little shortcut for squaring 2-digit numbers that end in 5. And again, the reason it works like this, of course, I have the formulas, and the other ones, of course, is because of this right here. Okay. These, of course, don't end in 5. Okay, so that's why I'm using the formula. But any number that ends in 5, you can use that same procedure that I just went over. Another shortcut that works nicely, and this one you can probably figure out, is when you're multiplying a two-digit number by 11. Okay, and the way it works is you simply bring the first and the last number down, leave some space in there, and then add the two digits 2 and 5, 275. Okay, 25 times 11 is 275. What are you going to do? Okay, now let's say you have 37 times 11. Okay, bring down the 3 and the 7, and then you add the digits. But in this case, 3 and 7, now if it comes out to just a single digit, then you split it in there, that's your answer. But if it comes out larger than 10, or 10 or larger, in this case, it's 3 times 10. This comes out to 10 here. But the answers are going to be 3,000, because this, you have to kind of carry this over to this side. So carry over the 1, and that becomes 4, 0, 7. Okay, so you can figure this formula out. The reason it works is by just doing it the long way, and you figure out why it comes out like that. So I don't need a special formula to show this. Let's say 77 times 11. Again, I would bring down the 7 and the 7, leave some space there, and then I would add the digits here. 7 and 7 is 14. And again, because it's a two-digit value here, I carry the 1 over, and this gives me 847. But see, you can do those calculations. I'm writing them down so you can see them, but you can actually do the calculations in your head. Okay, so this comes out to 847. Try another one. Let's say 97 divided times 11. Okay, so again, the rule is you bring down the 9, first digit and the last digit, use the space, and then add the two digits. And if it's a single digit, that'll be your answer. You split it in. But if it's larger than 10 or larger than, you have to carry. So in this case, you get 16. Carry the 1 over here. That gives me 10. So the answer comes out to 1,067. Okay. Now you can extend this procedure to 3 digits, and it's a little bit more involved, but there is a shortcut for that. But for this video, that's going to be it. I will follow up with some other shortcuts, and again, I will be using some of these formulas to really show you, because I want to give you these shortcuts, but at the same time, I want you to understand why they work. Okay, so thanks for watching, and we'll see you in the next video.